Alright, welcome everyone to day 15 of Advent of Code. Yesterday's was not too bad. We did it. It wasn't a challenge in the sense of day 13's part 2 was, but it was still a difficult problem. These are definitely becoming much more difficult problems for me. I'm reaching my kind of limits of what I know off the top of my head and can do quickly and can explain in the end, but hopefully day 15 is something I can do. It just points out we haven't done a pathfinding one this year yet, which is interesting, so I'm sure that's coming up. But anyways, 5 seconds till we get the problem here. 3, 2, 1, do this. You catch the airport shuttle and try and book your new flight to your vacation island. Due to the storm, all direct flights have been canceled, but a route is available to get around the storm. I'm sensing pathfinding. You take it. While you wait for your flight, you decide to check in with the elves. They're playing a memory game and you're so excited. Oh, maybe not. In this game, players take turns saying numbers. They begin by taking... This game, players take turns saying numbers. They begin by taking turns reading from a list of starting numbers your puzzle input. Then each turn consists of considering the most recently spoken number. If that was the first time the number had been spoken, the current player says 0. Otherwise, the number had been spoken before the current player announces how many turns apart the number is from when the previous spoken. Oh my, that's a tough game. So after the starting numbers, each turn results in the player speaking aloud either 0 if the last number is new, or an age if the last number is on repeats. For example, suppose the starting numbers are 036 or 00. The first number spoken and starting is 0. The second is 3. 6. Actually, the last number spoken is 6 since the first time the number is spoken. The fourth number is spoken to 0. Wait, what? Turn 4. Now consider the last number spoken 6. Since that was the first time the number had been spoken, the fourth number spoken is 0. Next, consider the last number spoken 0. Since it had been spoken before, the next number to speak is a difference between the number when it was last spoken and the previous. I'll get this turn 4. Now consider the last number spoken 6. Since that was the first time the number had been spoken, the fourth number spoken is 0. Okay, now again consider the last number spoken 0. Since it had been spoken before, the next number to speak is the difference between the turn number when it was last spoken 4 and the turn number. What do you think of the raid, man? Thus, fifth number spoken is 4 minus 1, which is 3. Oh my goodness. Oh, this is a short puzzle input. Okay, hold on. I can't even copy this. I'm trying to figure out this day 4, or the turn 4 thing. The game ends when the elves get sick of playing or dinner is ready, whichever comes first. The question for you is, what will be the 220th number spoken in the example above? The 220th number spoken will be 436. Here are a few examples. Okay. So given these inputs, actually I should probably start with this as the input, but we'll do whatever. So we need to, in this case, it's only, so we're going to have our string, let's do an integer array. Is it going to be equal to new integer, shoot, I don't know. Because there's going to be input strings, we're just going to get the first one and we're going to split on the comma there. So this will give us a num strings k. This is that. So I guess we'll start this after, and this will be num strings dot length. Okay. So first step is going to be just to copy these numbers and transform them into a list of numbers instead of strings. And num strings numbers, I can't do it this way. Int I equals 0 while I is less than. Num strings length I plus plus. Numbers I equals integer parse int num strings I. Okay. So now we have our numbers list, so we need to follow these rules. So we need to know what the 220th spoken number is, or 2020th spoken number is. So my question is, what is turn 4? Now, so because we've gone through this, the last number spoken was 6. Since that was the first time the number been spoken, the fourth number spoken is 0. So so you say the starting numbers and then you go on to the thing. Okay. So we're going to do, how are we going to implement this? I guess we could just do a backwards recurse. So basically we can keep track of a list here. We can just do a list of integers and we can just do this as spoken. This is probably not the most efficient way. I can almost guarantee you this. But this is just the way I can think of off the top of my head quickly. So we're going to have to do integer I in numbers. So I guess we don't need to do this. What we can actually do is remove this, and we can just do spoken add this way. We don't need those numbers. And this can become an enhanced for loop. Okay. So now technically we've gone through the first turn. So we're going to do a while spoken dot size is less than 2020. We're going to continue this pattern. So what we need to do is we need to pull off the last number spoken. And then we need to figure out if it was the first time that it was said. Okay, so we need to do int last equals spoken dot get spoken dot size minus 1. And now we need to do spoken dot sublist from 0 to spoken dot size minus 2. Is there a stream? And we need to we would need to reverse this because we want to go backwards. So actually streaming this isn't going to be helpful at all. So we're going to have to go backwards. This we're going to do for int I is going to be equal to spoken size minus 2 while I is greater than or equal to 0, I minus minus. And so what we're going to do is we're looking for this number to have occurred. Int index. So if it hasn't been occurred, we just say 0. And then, so we need also to keep track, well, we have the last, so that's easy. So we just need to know the index. Okay, so index last spoke equals -1. And what we do is we do a check here if spoken get I equals last. What we do is we set this equal to I, and we break out of this. Okay, so now we make a check here. If index last spoken equals -1, it means it has not been spoken, in which case we just do spoken add 0, and we continue on. Otherwise, it has been spoken, in which case we need to do the difference, which is going to be spoken add spoken dot size minus 1 minus the last index spoken, I believe. I don't want to do that. I think, and then that will give us a difference, which then input that in, and it'll continue the cycle. It's probably gonna get really slow, but we're going to run it for not that input. Well, we can just run it for input. Let's just see what happens. Oh, I didn't do lap or anything. Then what we need to do is after this, we need to do lap of spoken get index 2020. Oh, wait, 2019, because it's the 220 number spoken. My bad. 870, I don't have much hope, but maybe. I got it right. All right, I'll take it. I won't complain. I'll take it. I won't complain. All right, part 2. Impress the elves issue your challenge. Determine the, yes, this is where I'm about to fall apart, because that took 10 milliseconds. It's about to go downhill really quickly. So let's move this to a method here. Public, oh my goodness, void step. And then this needs this. So this is where it goes downhill. I can do that first part really quickly, but this next part isn't going to work. Not nearly as quick. So we're gonna do spoken there. I'm just doing this that way I can split this up again and then do this while it is less than this. Okay, I'm gonna be lazy. I'm gonna do that. So, yeah. So now we need to think of ways to improve this speed and efficiency. One way we can do this is by keeping track of the scene characters. So we would also need a list here of integers, and this is going to be scene. And this actually can just be scene last, can't it? This could be actually, no. We can make this much, much faster. We can do a map of an integer, and we can give it an integer, and this is just gonna be when it was last seen. So scene last equals new hash map, sorry. Cool, and so we can do this, and then all we need to do is that, and then we can implement scene last put we just put in this number, and it was scene last at spoken dot size other way around, put that there. Cool, and so now we can pass scene last into this step here and make our life a lot easier. So now instead of doing a reverse lookup, we can just consult with this scene last. So get rid of that. So in this case, the last is still there. So in this case, we just see scene last dot contains key of last. If it has this, we add we need to delay adding these by 1, I think. Wait, do we need delays by delay them by 1 step, I think, maybe? First number spoken 0. Now, actually, the last number spoken was 6. Since that was the first time the number had been spoken. Right, so we need to delay it by 1. So we do need a concept of the last said. Okay, so we pull that out. So we don't want to say, okay. For int I equals 0, while I is less than numstrings length, I plus plus. So that's me numstrings I. Okay. And what we're going to do here is we're going to check, so we also need an int last. We need to check if I equals numstrings dot length minus 1. If it does, last is equal to num, otherwise put it into here. So we need to keep this concept of the last number. Just invent -1 so that things are happy. So in this step, we also need a concept of the last spoken. Int last spoken. Okay, and then we're going to return that last spoken. So we're going to pass last spoken in. Oh, it's actually just last. Sorry, we're going to pass last in and we're going to set last equal to it. Okay. So now we have the concept of last, so we don't need this last, we just need last spoken here. So what we do is if this contains last spoken, we insert in a 0 and we return 0 as, or sorry, we add in last spoken and we return 0 because it was the last one spoken. Otherwise, what we need to do is if it does contain it, we need to still, I also need to do seen last, put last spoken at spoken dot size. Okay. Otherwise, we still need to put last spoken in again. So either way, we still put last spoken in. But in this case, we are returning. Oh wait. Oh, okay, but it doesn't matter. This is gonna be the same thing back to back. We're just returning different numbers. So in this case, we need to return and seen last temp is going to be seen last dot get last spoken, and we're going to return the spoken dot size -1 minus that. Please? No pointer where? Here. Oh, sorry, does not contain. The backwards. That was slightly faster. Oh, wait. Darn. Okay. Let's go through some of their examples. So it does get it, just takes just a second to get it. Was 036 one of their examples? No. Wait, yes it was. 036 was 436? Wait. .436, that's not right. Something's wrong. Oh, I'm off by 1. Wait, no, I'm right. I'm off by 1 because I forgot I changed spoken. I changed spoken to be off. We're holding it up by 1. So we need to know if the size is because we returned the last where we're holding off adding it. So it needs to be 2 so it's 219 and it's actually last. Hold on, so I need this to be 436, right? No. I need this number to be 436. There we go. Okay. So we're right, but we just want to do lap of last. Right, because we were going backwards 1. Okay, never mind. So 436, and then it's going to be that number, 17.5. Just to make sure before I stop it. Yes, okay. Now let's run this again. It's going to take just a second again. It's going to take just a second. It's not quite the fastest. It could definitely be faster, but we got it right. Hey, look at that. I feel like we did the first part pretty quickly. Maybe not. We definitely did the first part pretty quickly. I'm actually really happy with how fast we did today. I'm actually kind of impressed with myself. Okay, so for the explanation for today's question. So the question starts out with a memory type game where you're given some starting numbers that are said out loud. So the first person will say 0, second person says 3, third person says 6. After that, the next person to go, so for turn 4, takes into account the last number said. If that was the first time the number had been said currently in the game, they will say 0. Otherwise, they will say the difference between the first time the number was said and that last index. So in this case, for turn 5, since 0 had been spoken before, they will say 3 because 0 had been said at the last turn, which was 4, and the first turn, which was 1, which the difference of those is 3, so they say 3. Then the turn 6 takes into consideration the 3 had been said again by that last person, and then also by the second index, so they say 3 as well, and the cycle keeps continuing until, I guess, there's a random end. And the question here is they want to know what the 220th number spoken is. Hopefully the explanation of how the game works made sense. If not, you can read it there. But so for our case here, the first thing we need to do is we need to convert all of these strings into numbers. That way we can parse these much easier. And then what we do is we go through this step. We also keep track of what the last number said was, and we have a hash map here of all of the numbers and when they were last said, and of all these spoken numbers. That way we can get whatever index we need. So in this case 2020, or in this case 3 whatever. So for both parts, they're basically the exact same. They just are getting different indexes of what we want. For part 1, basically, or for both parts, what we're doing is every step we are taking into account the last number spoken. If that last number is spoken had been previously spoken, as it was in our scene list here, which is our hash map, if it was in that hash map, we just take the last index, or whatever was last, turn was last, and we subtract that off with what is in our hash map of the last said. If it is not in our hash map, then we need to add it with the current, or we need to add it with the current number said. Thing to note is this is technically one behind, so we are going off the last spoken. So when we say a word, we're returning that one, and we're adding the last one into our scene list. That way we have the last said, but that way we also have the index of when it was first said, because if we didn't do that way, we would be overriding it. So when we went back to essentially calculate the distance, we wouldn't have the distance because we've overridden it with the last said. So that's why we return the last number said, and we put in the one that was the last number said. It's a little confusing. It's a little confusing for me. If you can kind of grasp that we're working one behind and we're returning the last one said, it makes sense. But yeah, it probably makes more sense if you watch it while I'm doing it. But either way, part 1 and part 2 are basically the same. We're just grabbing different numbers, and the way you can improve your efficiency is by just having that hash map for it. But yeah, at any rate, hope you guys enjoyed this video. I'll see you guys all tomorrow for day 16. Peace out. Commit this. Now we have a way to go back on this. All right, so now let's switch this over to index. So let's do int index equals 0 to start. Wherever we add, we're just going to increase index is what we're going to do. And then wherever we do spoken.size, we're going to do index. And index, 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 index. Okay. Index, index plus plus. Oh, we can't do index plus plus in here, so we gotta do it in here. But luckily we don't need index -1 here, we just need index. Okay. In theory now, I mean, that was what I just had, wasn't it? Oh, I must have had something just off. There we go. I must have been just off then on one of what I placed stuff.